Welcome to Education Express. We'll continue with chapter expansion. Now, I hope you remember that first I completed 4A, then 4C, and now we are doing 4B. Follow the same order. So what exactly does 4B contains? We did square yesterday. That means we know how to find out the identity a plus b the whole square, a minus b the whole square. Let's recreate the whole thing. A plus b the whole square, done sir. A minus b the whole square, done sir. A square minus b square, done. This would be a square b square plus 2ab. This would be a square plus b square minus 2ab. This would be a plus b, a minus b. After that, relationship a plus b the whole square can be written as a minus b the whole square plus 4ab. This is a very important result. Then we have a plus 1 upon a the whole square can be written as a square plus 1 upon a square plus 2. And last, a plus 1 upon a the whole square can be written as a minus 1 upon a the whole square plus 4. This 4 and 6 are more or less the same. The only thing difference you can see is over here my second term is b, whereas the second term is 1 upon a, whereas everything is followed exactly in the same fashion. This is what was applicable for 4a. What was applicable for 4c was a plus b plus c the whole square can be written as a square plus b square plus c square plus 2 into a into b, so 2ab plus 2 into b into c, 2bc plus 2 into a into c, 2ac. Same way, a minus b minus c the whole square was a square b square c square, always square, does not matter what is the sign given to you in the center. After that, plus 2 into a into minus b, 2 into a into minus b, that will give you minus 2ab. 2 into minus b into minus c, that gives you plus 2bc. 2 into a into minus c, that gives you minus 2ac. So this is exactly what we are doing. I just showed you, or basically a recap of all the formulas that we have used so far for the purpose of solving all the questions pertaining to 4a and 4c. One more thing you need to remember, if x square equals to 60, x would be plus or minus 4. If x square equals to 10, x would be plus or minus square root of 10. And if x square equals to 80, x will be plus or minus square root of 80. But that's not the end. Why? Because we can further, this 80 is applicable for further arithmetic treatment. What is that? 80 can be written as 16 into 5. That means plus or minus. What is the square root of 16? 4. 4 root 5. So this was a recap of the entire formulas that we used for the purpose of solving 4a and 4c. Let's move on to 4b and see what are the formulas that are applicable for 4b. For the purpose of exercise 4b, following formulas will be important. A plus b the whole cube. Earlier we did square, now we are doing cube. A plus b the whole cube can be written as a cube plus b cube plus 3 into a into b and into bracket same a plus b. So basically when you expand, you get a cube plus b cube plus 3ab into a, that is 3a square b plus 3a b into b, b square. This is the result. But what we need to remember is, we need to remember a plus b the whole cube would be a cube plus b cube plus 3ab. 3ab is 3 into product of a and b, and then the same thing, whatever is the same thing, a plus b. This is the result of a plus b the whole cube. Same way in case if you have a minus b the whole cube, my result would be a cube minus b cube minus, see everywhere wherever plus was there, plus. Since over here minus is there, a cube minus b cube minus 3 into a into b, 3 into a into b, and then the same thing, a minus b. If you wish, you can open this, a cube minus b cube minus 3 a into a square, b minus becomes plus 3 a B into B, B square. So final result would be this, but when we will apply the formula, we will start and begin with this only. So this is the formula for A plus B the whole cube. This will be the result applicable for the purpose of A minus B the whole cube. In case if we get A plus 1 upon A the whole cube, I would say that this is nothing but exactly the same thing, whereas B has got substituted with 1 upon A. Again, treating this as a B only, A cube plus 1 upon A cube. That means A cube plus B cube plus 3 into A into B, and then A plus B. So when you expand this further, you get A cube plus 1 upon A cube. If you observe, A and A will get cancelled. What remains is 3, A plus 1 upon A. So whenever I get A plus 1 upon A, the whole cube, my result will get formulated in this form only and not this. This was just to show you the expansion part, but this is what exactly I am going to follow. Similarly, if you have A minus 1 upon A the whole cube, it would go as A cube minus B cube minus 3 A minus 1 upon A. So the four formulas in nutshell that you need to remember for the purpose of this exercise would be A plus B the whole cube, which we know A cube plus B cube plus 3AB A plus B. You can copy it down. A minus B the whole cube, that would be A cube minus B cube minus 3AB A minus B. A plus 1 upon A the whole cube, that would be A cube plus 1 upon A cube plus 3 A plus 1 upon A, and finally A minus 1 upon A the whole cube can be written as A cube minus 1 upon A cube minus 3 A minus 1 upon A. Sorry, excuse me. In case if you are very well versed with, familiar with these four formulas, there is no need for you to look out for any other formula for the purpose of this exercise, for a very simple reason that this covers almost everything. Sometimes they may ask you what is the value of A cube plus B cube, but since this formula itself covers what is A cube plus B cube, so what you need to do is A plus B the whole cube and bring this portion that side. So automatically you can make A cube plus B cube as your subject. There is no need for us to remember any new formula for the purpose of A cube plus B cube or A cube minus B cube. Those can be answered by making A cube plus B cube as a subject. I'll give you a simple example. For example, if you have A plus B equals to C plus D. So many people may give you 4 different formulas for the same thing, same relation. A plus B equals to C plus D. They may say, see, I have this formula. A equals to C plus D minus B. Someone will say, I have a formula. B equals to C plus D minus A. Someone can say C equals to A plus B minus D by pushing this side. Someone would say B equals to A plus B minus C. Trust me, they are not 4 different formulas. They are the relationship between A, B, C, D, which can be extracted from here. So just to remember A plus B equals to C plus D, we will not follow this foolishness of remembering 4 different things, making A, B, C, D as their subject. So as and when whatever will be needed, we need to remember only this one single comprehensive formula, which is 4 in 1. There is no greatness lies in remembering the subject of each of them and memorizing them. Rather, you understand the application aspect of it with the relationship of A, B, C, D, which is devised in one single statement that A plus B equals to C plus D is given to you in this statement. So as per the requirement, you can make any variable, any alphabet as your subject and get your desired answer. I hope the thing is very clear. Let's move on to the questions which are there in exercise. Let us do the following questions. Few of them have been picked up from the textbook and few of the questions I have given you as an extra questions for the purpose of practice. A minus B the whole cube. That would be A cube minus B cube. Talk to yourself. Minus 3 into A into B. A minus B. A cube minus B cube minus 3AB, A minus B. You can write that identity. That means identity of A minus B the whole cube. Now it comes to solving 5 cube. 5 into 5, 25, 25 into 5, 125. A cube. 2 into 2, 4. 4 twos are 8. 8b cube. Minus 3 into 5, 15. 15 into 2, 30. 30ab. 5a minus 2b. Move on to the next one. 125a cube minus 8b cube minus 30 into 5, 150. A into a square, and b. Minus into minus, that makes plus. 30 into 2, that makes 60. A. B into b square. This is how patiently, if you follow the result, identity, you are bound to get the answer. Look at this question. 2a plus 1 upon 2a the whole cube. A cube plus b cube plus 3 into a into b, and after that a plus b. Now focus on this. 2 cube of 2, 8a cube. Same way, this would be 1 upon 8a cube plus 2a will get cancelled. 3 into bracket 2a plus 1 upon 2a. I am sure this can be further expanded. 8a cube plus 1 upon 8a cube plus 3 into 2, 6a plus 3 into 1, 3 upon 2a. Remember, numerator will get multiplied only with numerator and not denominator. My denominator will remain the same. So, my final answer would be this. It's a very simple process. Just apply the formula. Apply, supply, get the reply. A minus b the whole cube would be a cube minus, I hope you remember, a cube minus, same thing we have done over here, b cube minus 3 a minus b. So if you further solve it, 3 3s are 9, 3s are 27, x cube minus 125 y cube minus 3 3s are 9, 9 5s are 45 xy, 3x minus 5y. So if you go further, 27 x cube minus 125 y cube minus 45 into 3, 135 x into x square. What remains? Y. Minus into minus, that makes it plus. 45 5s are 225 x y into y square. How? Isn't it very simple? Of course. So if you practice these questions along with me, I am sure you will get the answer. A cube plus b cube plus 3 a plus b. 4 4s are 16, 4s are 64, a cube plus b cube. 3 4s are number to number, 12, a into b, ab, 4a plus 4, a cube, b cube. 3 4s are 12, 12, a into b, ab, 4a plus b. 64 a cube same as it is, b cube plus 12, 12 4s are 48, a into a square, b comes down, plus 12, 12, a, b into b square. It's as simple as that. Have a look at this question. X minus 7y the whole cube, a minus b the whole cube, a cube minus b cube minus 3 a minus b. Now when you open this, x becomes x cube, 7y cube becomes 343, y cube minus 3 into 7, 21, x into y, xy, x minus 7y as it is. X cube same to same minus 21. Now 21x multiplied by x is 21x square y, 21x square y. Minus becomes plus. 21 into 7, 147. 21 into 7, 147. Minus becomes plus. X, y becomes y square. Now this question, See, you have a number and then you have a fraction over here. We are going to follow the same mechanism. A cube minus b cube minus 3a b a minus b. So when we expand this, 3 becomes 27, x cube, 2 will become 8, y cube minus 3, 3 3s are 9, 9 into 2, 18, x, and down if you go to see in the denominator we have y, 3x minus 2y. Remember one thing my friends, all the numerators will get multiplied together. Numerator will not go to denominator, denominator will not go to numerator. So 3 into 3, 9, 9 into 2, 18, 18x upon y. From here on, 27x cube minus 8 upon y cube minus, pay attention my dear friends, 18 3s are 54, x into x square, all the numerators are multiplied, level plane, all the numerators upon y, minus into minus plus 18 into 2, that's 36, x. And now you see this denominator, y into y square. As I told you, numerator will multiply by numerator, denominators will multiply by denominators. So this is what will be your exact answer. I am giving you a few questions for practice purpose. You need to practice the following questions in addition to the questions that I have done. So the additional questions would be 3a minus 5b the whole cube. Please copy it down. 4x minus 3y the whole cube, 7p minus plus 2 upon p the whole cube, 3x upon 2 plus 4y upon 3 the whole cube, and finally 3 upon 5 minus 2 upon 7x the whole cube. These 5 questions are extra questions for practice in addition to entire exercise 4a, 4c plus 4b. So my dear friends, we will start with exercise 4b. Remember, this exercise is little difficult as compared to what we have done so far. You need to be really attentive. So kindly pay your attention, listen to all the instructions that I will be giving to you for the purpose of solving this exercise. It is very important, essential, very essential exercise, not only from this chapter perspective, but the next chapter that will be followed, that is factorization. There also we are going to make lots of application of the properties that we learn in this exercise. Have a look at this question. See, understand the nature of the question first. A square plus 1 upon a square. So a square plus 1 upon a square equals to 47. They have given you the detail or the data or the given aspect in square terms. Alright, so one thing is sure, in your answer, somewhere square will get involved. What do you have to find? A plus 1 upon a. If I have to find a plus 1 upon a, can I say something like this? Sir, a plus 1 upon a square can be written as a square plus 1 upon a square plus 2. A square plus b square plus 2 into a into b. Of course. Now see, when I write this, how do I know that I have to find the square? Because square was given to me. And a plus 1 upon a is what I have to find. So the formula which can bring both of them together on the same platform would be this. So I am trying to find out the value of this. A plus 1 upon a square equals to a square plus 1 upon a square, which is given to you as 47 plus 2, that makes it 49. Since a plus 1 upon a, the whole square is 49, therefore a plus 1 upon a would be plus or minus 7. How simple! It was absolutely simple. We only correct the first part of it. Now you have two values of a plus 1 upon a. A plus 1 upon a is 7, or a plus 1 upon a could be minus 7. These are the two possible values of a, which we have got from here. They are asking us to find the value of a cube plus 1 upon a cube. My dear friends, can you please tell me which formula will involve a cube plus 1 upon a cube? The answer is a plus 1 upon a, the whole cube. Let's take the cube of it. What do you get? A cube plus 1 upon a cube plus 3a plus 1 upon a. I hope you remember the four formulas that I have introduced to you. A plus b, the whole cube equals to a cube plus b cube plus 3ab, a plus b. A minus b, the whole cube equals to a cube minus b cube minus 3ab, a minus b. A plus 1 upon a, the whole cube equals to a cube plus 1 upon a cube plus 3, a plus 1 upon a, and finally a minus 1 upon a, the whole cube equals to a cube minus 1 upon a cube minus 3, a minus 1 upon a. So basically I have to adopt one of the formula. This seems to be more preferred option. So I am going to apply a plus 1 upon a, the whole cube would be a cube plus 1 upon a cube plus 3 a plus 1 upon a. In this, let's substitute the value of a plus 1 upon a. How much is that? 7. 7 cube equals to a cube plus 1 upon a cube. Now this is the part which I have to find, which is unknown. Plus 3 a plus 1 upon a. A plus 1 upon a is 7 in this example. 7 sevens are 49, sevens are 343 equals to a cube plus 1 upon a cube plus 21. Please bring 21 on this side. 343 minus 21 will give you a cube plus 1 upon a cube. Therefore, my final answer, a cube plus 1 upon a cube, would be 343 minus 21, that is 322. This is very important question. And my dear friends, remember, finding a plus 1 upon a the whole square, the objective is to find out a plus 1 upon a. We are going to get two distinct values of a plus 1 upon a. One is positive, the other is negative. So though we got the answer a cube plus 1 upon a cube is 322, if you would have taken this, then in that case my answer would be minus 322. How am I going to get minus? Have a look. Same formula if I follow, then I just have to substitute the value as minus 7. I am going to follow the same formula. A plus 1 upon a the whole cube. So a plus 1 upon a over here is minus 7. The whole cube equals to a cube plus 1 upon a cube. A cube plus 1 upon a cube plus 3. The value of a plus 1 upon a will be minus 7. So 7 sevens are 49, sevens are 343, but negative, because negative is there, value is minus 7. A cube plus 1 upon a cube minus 21 minus 343. Please bring this 21 on this side. Plus 21 would be a cube plus 1 upon a cube. So a cube plus 1 upon a cube would be minus 322. So one thing is for sure, if I am getting two values and if I have to use those two values in the subsequent part to find out the desired result, then again I am going to get the two values. Now this is mandatory. What working I have shown, that working is mandatory. Although we know that we are going to get the two answers, one will be positive, other will be negative. In spite of that, doing this working note is mandatory for two reasons. The reason number one, you have to show your working by substituting both the values. One is positive and the other is negative. And this is exactly what they have done in the textbook also. In many schools, though they don't do, they skip the two alternative methods and they ask the students to just write plus and minus 322. That is also acceptable as long as the teacher in the school approves it. Or else, to be on the very safer side, where there is no controversy, where you are always right. Why? Because I am following exactly what has been shown in the textbook, wherein I will show my working for both plus and minus. So to be always on the safer side. But yes, in case if there are any special instructions which is given to you in the school with respect to solving this, that the teacher will allow you or give you a concession or will be lenient with respect to showing only one working and showing both the values of plus and minus in one working only, and even that is acceptable. So please talk to your teacher with respect to this and follow the instruction what has been given in the school. And if you want to ignore that, you can show both of them. In that case, you are safeguarded, completely safeguarded, and there is no need for you to listen to any instruction. Alright, let's move on to the next question. Question number 3. In question number 3, again, have a look. A square plus 1 upon a square. So square is involved. So somewhere in my solution, square will get involved. But which square? A plus b the whole square or a minus b the whole square? What we have to find? A minus 1 upon a. See the contrasting view. Here we have to find a plus 1 upon a. So I took a plus 1 upon a square. Here I have to find a minus 1 upon a. So what I do is a minus 1 upon a. The whole square can be written as a square plus 1 upon a square minus 2. This is same as a minus b the whole square. A square plus b square minus 2a. Can we substitute the values? Yes sir. A plus 1 upon a square is 18. 18 minus 2 is 16. So a minus 1 upon a, the whole square, is nothing but 16. In that case, a minus 1 upon a would be plus or minus 4. I hope you remember we have done the same thing over here as well. So again, two things will follow. But the fact is, understand, the question over here involved cube. But the question over here is simple. A square minus 1 upon a square. How do you get a square minus 1 upon a square? So a square minus 1 upon a square will follow the formula a square minus b square, that is a plus b, a minus b. So here this would be a plus 1 upon a minus 1 upon a. Do we have the values? Sir, I only have a minus 1 upon a. I don't have a plus 1 upon a. So how do you get a plus 1 upon a? We'll have to work out to find out the value of a plus 1 upon a. Now please recall your memory back to the first exercise. I told you one of the most important formula is the linking formula. You can find the value of a plus 1 upon a, the whole square, by using the linking formula. That means it links between a plus 1 upon a and a minus 1 upon a. So a plus 1 upon a square can be written as a minus 1 upon a square plus 4. Do you have the value of a minus 1 upon a? Yes sir. So what value do you have? Whether you write plus 4 or minus 4, because it is a square, so certainly my answer over here would be 4 square, that is 16. 16 plus 4, that is 20. That means a plus 1 upon a square would be 20. So why did you write over here 16? I wrote over here 16 for a very simple reason. If the value of a minus 1 upon a is plus 4 or minus 4, the result would be the same. If I write 4, yet I am going to get 16. If I write minus 4, yet I am going to get 16. So 16 plus 4, 20. A plus 1 upon a square becomes 20. So a plus 1 upon a becomes plus or minus square root of 20. That's not enough. A plus 1 upon a would be plus or minus. This can be written as 4 into 5. Therefore, a plus 1 upon a would be plus minus 2 root 5. We have only found out the value of a plus 1 upon a. Have a look at the question. I want to find out a minus 1 upon a given square. So I will expand this. A minus 1 upon a square is a square plus 1 upon a square minus 2. Can I substitute the values? Yes sir. A plus 1 upon a square is given to you as 18. 18 minus 2 is 16. So a minus 1 upon a square becomes 16. So a, of course, one more thing you can think. I'll tell you what. In case, if as we know that the value of a minus 1 upon a equals to plus or minus 4, this is what is the desired part. In this part, a plus 1 upon a square equals to a minus 1 upon a square plus 4. As you know, a minus 1 upon a square, see this value is already obtained. A minus 1 upon a square is 16. So I am substituting the value 16 plus 4 is 20. A plus 1 upon a square equals to 20. A plus 1 upon a would be plus or minus root 20. A plus 1 upon a equals to plus or minus root 20 means 4 into 5, and then we get this. Still we have not covered. Still we have not completed what is asked. What is asked is a square minus 1 upon a square. So a square minus 1 upon a square is nothing but a plus 1 upon a minus 1 upon a. So why? It is a square minus b square, which is a plus b, a minus b. Now, do you have the value of a plus 1 upon a? Yes, sir. Plus or minus 2 root 5. Do you have the value of a minus 1 upon a? A minus 1 upon a? Yes, sir. Plus or minus? So my final answer would be plus or minus 8 root 5. So how? 2 into 4, which is 8, and root 5. This is the final answer. I hope you will thoroughly practice this concept. They are very, very important, very, very material. And once you get hang of it, I am pretty sure you will love them and you will do it lots of interest. Let's move on to the next one. This was question number 2, question number 3. Move on to question number 5. Now, when you look at question number 5, a plus 2b equals to 5. That's given. Show that a cube plus 8b cube plus 30ab equals to 125. Now, whatever part I have to prove that involves cube, have a look, that involves cube. So, can I say something like this? In my solution to this question, I can say that since a plus 2b equals to 5, if I take cube on both the side, it will be a plus 2b. The whole cube will be equal to 5 cube. Why, sir? Taking cube on both the sides. So I have to take a cube because I need to get cube in my desired part. That is what they expect me to do so. How you expand this? A cube plus b cube plus 3a b a plus b. What about this 5 cube? It becomes 125. A cube, 8b cube, 3 into 2, 6. AB, a plus 2b equals to 125. Everything seems to be going very smooth. A cube, 8b cube, 6ab. My dear friends, have a look over here. A plus 2b. We already have the value of a plus 2b. It's given to us. A plus 2b equals to 5. Please substitute the value as 5 equals to 125. Then what? A cube plus 8b cube plus 30ab equals to 125. Hence proved. So I'm sure this was a pretty simple question based on the same type of question. Have a look at question number 7. What they are asking us: a plus 2b plus c equals to 0. See, a cube, that means cube of this, 2b cube, that means cube of this, c cube of this. So basically they are expecting us, or indirectly they are asking us to take the cube on both the sides. In case if I take cube on both the sides, my dear friends, a plus 2b plus c, the whole cube, we don't have any result for it. We have done a plus b plus c square, but not cube. Cube we have done only for 2 terms and not for 3 terms. Then how do we go about? What we can do over here probably is a plus 2b plus c equals to 0. So a plus 2b equals to minus c. Now I am shifting this c on the other side. Now if I take cube on both the sides, a plus 2b the whole cube equals to minus c the whole cube. Pretty safe? Can we take the cube on this side? Yes, expand it. A cube, b cube, a cube plus b cube plus 3a b a plus b equals to minus c cube will become minus c the whole cube. So a cube will translate into a cube only. This will translate into 8b cube. This will be plus 3 into a into 2b, 3 into 2, 6, 6ab plus 6ab, a plus 2b. My dear friend, this is the most important part. Have a look, a plus 2b, a plus 2b, a plus 2b is nothing but minus c. So I am substituting this as minus c. Very important part. This is the most important part of the whole sum. A is equal to minus c cube. From here on, if you see a cube, 8b cube, this will be minus 6abc equals to minus c cube. Bring this c on this side. A cube plus 8b cube plus c cube. That is what they want. Have a look. A cube plus 8b cube plus c cube. They don't want anything else on this side. So let's shift this that side. That becomes 6ABC. This is how we prove it. There is very important and interesting property related to this where they say that if sum of three numbers equals to 0, if sum of three numbers equals to 0, then if sum of three numbers equals to 0, then a cube, the sum of their cube, b cube plus c cube, sum of their cube will always be equal to 3 times their product, a to b to c. That means 3abc. A cube plus b cube plus c cube. Now this is possible, this formula is applicable if and only if a plus b plus c equals to c. Question number 8 gives you entire insight with respect to applicability of this formula. I'll give you one small illustration just to put my point in perspective. The small illustration is, have a look over here. Let us say a equals to 1, b equals to 2 and c equals to -3. Tell me what will be the sum of these three numbers. A plus b plus c. So sum will be 1 plus 2 minus 3. That will be 0. So without solving, I can tell you that a cube plus b cube plus c cube. That means cube of this plus cube of this plus cube of this. Without solving, I can answer you. A cube plus b cube plus c cube will always be equal to 3 into a into b into c. You can verify. So let's check 3 into a. What is the value of a? 1. Into b, 2. Into this. Have a look. 3 into 1, 3. 3 2s are 6. 6 into 3, 80. Negative 80. Let us check by actually finding it. 1 cube, 1. 2 cube, 8. 3 cube, minus 27. 9, minus 27. Oh yes, sir. So in short, finally, if a plus b plus c equals to 0, then a cube plus b cube plus c cube is nothing but 3 into product of all the three numbers, that is a, b and c. We are going to continue with question number 8, which has or probably will be using the same property as what we have discussed now. Alright, let's read the property. As I said, if a plus b plus c equals to 0, then a cube plus b cube plus c cube is nothing but 3 into a into b into c. Have a look. 13 cube plus minus 8 cube plus minus 4. So can I say let a equals to 13, b equals to minus 8, c equals to minus 5. So a plus b plus c would be 13 plus minus 8 plus minus 5. 13 minus 13, that is 0. So one thing is confirmed, that a plus b plus c equals to 0. If you have to find out the cube of this, that means you have to find the cube of a cube plus b cube plus c cube, which is nothing but 3abc. So minus 13 cube plus minus 8 cube plus minus 5 cube. You don't have to actually find out 13 into 13 into 13 or 8 into 8 into 8. Don't do that. We have a property a plus b plus c equals to 0. I proved it that a plus b plus c is indeed equal to 0. So this is nothing but 3 multiplied by a. What is the value of a? We have assigned 13. B minus 8. C minus 5. When you do the product of this, 5, 40, 40 3s are 4 3s are 12, 120 into 13. 12, 13, 144, 156. Even if you do it manually, you are going to get the same answer. So you see how maths is so very vital and important because of its properties. Have a look at the next question. 9 cube minus 5 cube minus 4 cube. Let a equals to 9, b equals to minus 5, c equals to minus 4. A plus b plus c will be 9 plus minus 5 plus minus 4. That will be 0. Again we can apply the property. What is the property? A cube plus b cube plus c cube equals to 3 times ABC. In place of a, 9 cube plus minus 5 cube plus minus 4 cube would be 3 times 9 into minus 5 into minus 4. 5 4s are 20, both are negative, so becomes positive. 20 into 3, 60 into 9. That makes up 540. My friends, this is exactly how we are going to do it, and it's already done. Alright. Let's start with little more challenging questions. There is question number 9, 10, 12, 13. Have a look at question number 9. A minus 1 upon A equals to 3. That is what is given to us. A minus 1 upon A. What we have to find? A square plus 1 upon A square. So undoubtedly we have to use the formula of square. Squaring on both the sides. A minus 1 upon A square will become 3 ka square 9. Can we expand this? Oh yes sir. A square plus 1 upon A square minus 2 equals to 9. Since I want this part, A square plus 1 upon A square, so what I'm going to do is, I'm going to transfer minus 2 on that side. That becomes 9 plus 2, 11. So I get my first one. How do I identify? From A minus 1 upon A, I have to reach to a square. The only option is squaring on both sides. Since I have A minus 1 upon A equals to 3, and I want cube, I will take cube on both the sides. How? A minus 1 upon A equals to 3. So A minus 1 upon A cube will be equal to 3 cube. Taking cube on both the sides. Why so? Because I am interested in finding the cube. Can you expand that? Of course, A cube minus B cube minus 3 is 1 upon A will give you 27. We have already discussed about the identity A minus 1 upon A, the whole cube can be written as A cube minus 1 upon A cube minus 3 A minus 1 upon A. This is the importance of the identities. This is the importance of all the formulas. One must remember all the formulas while doing this chapter, because that formula is only key to basically proceed and to connect all the dots. In case you really want to connect all the dots to see the real picture, you must know all the formulas on the fingertips. Slowly and gradually, as you practice, you will get to know where to apply which formula. The application aspect depends upon what is given and what is asked. Given is A minus 1 upon A, asked something in the nature of a square, you need to take a square on both the sides. Again over here, A minus 1 upon A, they have asked you square, so I am taking cube, cube, so I am taking cube on both the sides. Let us substitute the values. A cube minus 1 upon A cube minus 3. What is the value of A minus 1 upon A? A minus 1 upon A is 3 equals to 27. Therefore, A cube minus 1 upon A cube. This will result in minus 9. The minus 9 when goes on that side becomes plus 9. So 27 plus 9, that becomes 36. So this is my answer. First part of the answer is 11. That is A square plus 1 upon A square. The second part of my answer is 36. This is how exactly we are going to do it. Have a look at the similar type of question, that is question number 10. A minus 1 upon A is 4. Same like A minus 1 upon A is 3. A minus 1 upon A is 4. They are asking me to square it. So what do? 1 minus A minus 1 upon A equals to 4. A minus 1 upon A square will be 4 square. Can you expand this? A square plus 1 upon A square minus 2. This is A minus B the whole square. So same formula will give me 16. A square plus 1 upon A square will be 16 plus 2. That is 18. This is the first part of the answer. So as you know that A square plus 1 upon A square is 18, and I want A raised to 4. What I do is A square plus 1 upon A square, I will square on both the sides. Because if I take a square of this, only then there is certainty of getting A raised to 4. So this will become 18 square. What is the formula? A square plus B square plus 2 into A into B. I hope you remember the identity that we have applied in the very first exercise. I could have directly written A raised to 4 plus 1 upon A raised to 4 plus 2. But just to make you understand how it works, I have elaborated. This 2 will get cancelled, finally we get 2. that is 324. So a raised to 4 plus 1 upon a raised to 4 will be 322. I hope this is very certain. Since I wanted square, so I took square. Then I wanted a raised to 4. So square was available. I took a square of the square, which will help me get a raised to 4. Now I want a cube. So of course, if you want cube, we will take cube on both the sides. A minus 1 upon a cube can be written as 4 cube. So from here on, expand the formula. A cube minus 1 upon a cube minus 3a minus 1 upon a. This is the identity already discussed earlier. 4 cube 64. A cube minus 1 upon a cube minus 3. I already have the value of a minus 1 upon a, that is 4. Substitute, you get 64. A cube minus 1 upon a cube. This will result in minus 12. Minus 12 goes on that side. 64 plus 12. So a cube minus 1 upon a cube will result in 76. This is your third part. Isn't it simple, my friends? I'm sure you will enjoy it. And every time if you discipline yourself, if you recollect, remember the formulas, practice the formulas, all these things will become a very simple cakewalk for you. Have a look at question number 12. 2x minus 3y equals to 10. xy equals to 60. So two information has been given to me. My focus should be what is asked. 8x cube. So it involves cube. So my focus should be that I have to take cube on both the sides. Have a look. 2x minus 3y equals to 10. If I take cube on both the side, 2x minus 3y, the whole cube will be 10, the whole cube. Why I am taking cube? Because they are asking me something in terms of cube. A cube minus b cube minus 3. I hope you remember a minus b the whole cube is a cube minus b cube minus 3 a b a minus b. What is the cube of 10? 1000. This will give me 8x cube. This will give me 27y cube. 3 2s are 6, 6 3s are 18. xy 2x minus 3y equals to 1000. Pay attention, my dear friends. Very interesting aspect over here. Very interesting parts. 18. What about xy? Already given to me xy 16. That's so nice. What about 2x minus 3y? So that is also given to us as 10 equals to 1000. 8x cube. Pay attention. Very interesting part. 18 into 16, 288 into 0. Oh, I'm sorry, into 10 equals to 1000. 8x cube minus 27y cube equals to 1000 plus 2880. Therefore, 8x cube minus 27y cube will be 3880. Isn't it interesting? Of course it is. Alright, question number 10, question number 12. All these questions are so very interesting and important. If you follow the formula, all of them will surely be a game changer for you as well. Alright. Question number 13, sub question 1. I want to find the product of these two numbers. You can do it by mere expansion. 3x into the whole thing plus 5y into the whole thing plus 2z into the whole thing. Accepted. But in case if you want to do it little more smartly, what you can do is, there are two terms which are identical. You can check it. They are identical. No change of sign also. What you can do is bring those two terms which are identical together. So 3x plus 2z plus 5y. 3x plus 2z minus 5y. Now what happened is, this part you can treat it as A and this part as B. Have a look. If this part is A and this part is B, so you get A plus B, A minus B, because this were identical. So you can say 3x plus 2z, A plus B, A minus B, A plus B into A minus B is A square minus B square. A square minus B square. Simply expand it as you know how to expand them. A square plus b square plus 2ab identity minus 25y square. So you get 9x square, 4z square, 2 3s are 6, 2s are 12xz minus 25y square. Very simple question. Similarly, which two terms are identical? You need to first make sure which two terms are identical. See the second aspect of it. As I told you, which two terms are exactly identical? 3x identical minus 5y identical. What we can do is 3x minus 5y the whole square minus 2z the whole square. This was self-adjusted, so we didn't need to do anything because it was already self-adjusted. And then following the same rule, expand this, automatically will get your answer. Alright, let's move on to the next one, question number 14. Now what does question number 14 says? It says the sum of two numbers is 9. So let numbers be x and y. Sum of two numbers 9. And their product is 20. So x into y is 20. Find sum of their squares. And also find sum of their cube. Oh, this question seems to be a very simple one. Since x plus y is given and they are asking you square, x plus y equals to 9. Taking square on both the side, x plus y the whole square would be 9 square. X square plus y square plus 2xy equals to 81. Do we have the values? Any of the values? Have a look here. X square, this is what we have to find. Y square plus 2. What is the value of xy? 20. Substitute it. So you get x square plus y square plus 40 equals to 81. That means x square plus y square will be 41. Fantastic. What about cube? Same thing you're going to follow with the cube as well. X plus y equals to 9. So x plus y, the whole cube will be 9 cube. You have direct identity for this. Y cube plus 3 xy, x plus y equals to 9 9s are 81, 9s are 729. X cube plus y cube plus 3. Do you have the value of xy? Yes sir, that's 20. What about the value of x plus y? That's 9. That's also given to us. 729. X cube plus y cube. 3 2s are 6. 6 9s are 54. 729. X cube plus y cube equals to 729 minus 5 49. 9, 12 minus 8, 6, 189 is your answer. So, such questions are so simple. I think you can easily manage them. Move on to question number 15. Two positive numbers are x and y. It's clearly mentioned that both x and y are positive numbers, such that x greater than y, given that x and y both are greater than 0 because both are positive numbers. So, I have not done anything except for writing the information. X is greater than y and x, y both are greater than 0 because both are positive numbers. If the difference of these numbers is 5, that means x minus y equals to 5. This information is given to us in the question. And their product is 24. Product of these two numbers is 24. So x minus y given to you, x into y given to you. Find sum of these numbers. So first thing I have to find is sum of the numbers. Second, difference of their cube, x cube minus y cube. And third part, sum of their cubes, x cube plus y cube. I'm sure you guys will be able to do it very easily. The first part is related to the first exercise, the relationship between x plus y square and x minus y square. So it is again reinforcing into your mind the same thing what we did earlier. It's a recap. X plus y the whole square equals to x minus y the whole square plus 4xy. Do you have the value of x minus y? Yes sir. 5 square plus 4. What is the value of xy? 24. 25 plus 96. That makes it 121. x plus y square equals to 121. Therefore, x plus y equal to only 11, as x and y are positive number. So no way you can write plus or minus. This is only situation where I have eliminated negative sign for a very simple reason that we have mentioned that x and y both are positive numbers. Otherwise, I would have taken plus or minus. So no plus or minus, only positive numbers. Since x plus y given to you, you have to find x cube minus y cube. So you will simply say x plus y the whole cube equals to x cube plus y cube plus 3xy x plus y. X plus y available, x plus y, yeah, we found out 11. 11 cube equals to x cube plus y cube plus 3. What is the value of xy? 24. And x plus y 11. 1331 equals to x cube plus y cube plus, this is 72 and 9, 792. So 1331 minus 792 will be x cube plus y cube. Therefore, x cube plus y cube will be equal to 11 minus 2, 9, 3, 12, 3, 12, 5, 5, 13, 9. Same way we can find the value of x cube minus y cube. How so? X minus y, the whole cube, would be x cube minus y cube minus 3xy. X minus y. Substitute the values. X minus y is 5. 5 cube minus x cube minus y cube minus 3. What is the value of xy? 24. What is the value of y? 5. So all the values substituted. 125 x cube minus y cube. 25. 24 into 5, 120. 120 into 3. 360. 360 added to this. It becomes 485 equals to x cube minus 1 cube. Question of the exercise, question number 16. 4x square plus y square equals to a. xy equals to b. We have to find 2x plus y equals to how much? See, by mere observation you can come to know that the squares are given, whereas the number is over here. What is the square of 2x? 4x square. What is the square of y? Y square. So what we can do is 2x plus y whole square equals to a square plus b square plus 2 into a into b. What is the value of 2x plus y? We don't know. When I expand this, I get 4x square plus y square plus 2 is 4xy. Do you have the value of 4x square plus y square? Yes, sir. What is that? A. Plus, do you have the value of xy? Yes, sir. What is that? B. 4b. Therefore, 2x plus y, the whole square equals to a plus 4b. Therefore, 2x plus y will be plus only minus square root of a plus 4b. This was a very simple question. With this, my dear friends, we are already through 4a, exercise 4b, exercise 4c. Now I request all the children and the parent to ensure that children have done their homework in time. I want them to complete with entire all the questions of 4a, 4b, 4c. In case if you are doing my homework regularly, I can assure you that you will understand each and every aspect, each and everything that we have discussed so far. In case of any doubts or difficulties, you can approach me anytime. You can call me, you can WhatsApp me your doubts or difficulties. I will surely address your doubts and difficulties as early as possible. And in case if we have left some questions in between, hardly, I mean like probably out of every exercise where we have 15 to 16 questions, I have tried doing more than 12 to 13 questions. So the remaining 2 or 3 questions which was not done, that was deliberately not done with the objective of giving some practice to the children so that they can try and do things by themselves. In case if they get stuck, they will surely coordinate with me, they will inform me, and I will definitely help them with those sums as well. Also, one thing should be noted, that the questions which you have not done over here in the class, the solution to all the questions will be provided to you in your respective WhatsApp group. So do have a check on that. Make sure that your kids are doing work regularly, and in case if you would like to have any word with me, you are free to call me and give your suggestion. Thank you so much for watching the video. I love you all.